Consider a 3-digit code ABC where each O, A, B, and C is assigned one of the values 1, 2, 3, 4, or 5. A. Find the total number of possible codes, assuming that each value can be repeated. So there are 3 places, and if each value can be repeated, at the first place there may be any of these 5 values, so there are 5 variants to be on the first place, and also there are 5 variants, it may be one of these 5 numbers to be on the second place because each value can be repeated, and also there are 5 variants to be at the third place. So there are 5 cubed or 125 variants or codes in total. The second situation assuming that no values is repeated, and at the first place it is possible that there may be 5 numbers, any of these 5 numbers, so there are 5 variants, and since values cannot be repeated, at the second place it may be any of the remaining 4 values, so there are 4 variants, and at the third place there may be any of the remaining 3 numbers. So the total number of variants or codes is 60, or it can be calculated as a number of permutations 3 out of 5. 3 because we need 3 numbers out of 5, but a formula is given in a data booklet, it's also 60, but why is it a number of permutations, not combinations? It's because the order is important here. 1, 2, 3 and 3, 1, 2 are different things here, and a number of permutations is the same as the number of combinations 3 out of 5, but if we consider number of combinations, we choose a group 3 out of 5 of indistinguishable items. Order is not important, but if order is important, within each of chosen group there are 3 factorial ways to rearrange them, and a number of combinations 3 out of 5 multiplied by 3 factorial is the same as the number of permutations 3 out of 5. The next, let P of x be x cubed plus ax squared plus bx plus c, where each of a, b, and c is assigned one of the values 1, 2, 3, 4, 5. No values is repeated. Consider the case where P of x has a factor of x squared plus 3x plus 2. Find an expression for b in terms of a. Since it is given a factor and we know a remainder theorem, and the remainder theorem says that if we know a factor, a polynomial is divisible by this factor without a remainder, or remainder is equal to 0, so we can divide a given polynomial by this factor and consider a remainder, equating it to 0. We can get some equation, and hence we will try to get the relation between given parameters. Notice that a given factor has roots -1 and -2, and can be represented as x minus 1 multiplied by x minus 2. I will do a long division, but you may do a synthetic division twice. It doesn't matter, so let's do a long division. So we divide x cubed plus ax squared plus bx plus c by x squared plus 3x plus 2. What should be multiplied by x squared to get the greatest power here? So we consider the greatest power here and the greatest power here. And what should be multiplied by x squared to get x cubed? It's x. So we write x here. Then we multiply x by this and write here. So it becomes x cubed plus 3x squared plus 2x, and then this row minus this row, and it becomes a minus 3x squared. We can factor out x squared, and we can factor out x to get b minus 2 times x plus c. And again, we consider the greatest power here and the greatest power here. What should be multiplied by x squared to get a minus 3x squared? It's a minus 3. So we write plus a minus 3, and we multiply a minus 3 by each term in this expression. So it becomes a minus 3x squared plus 3a minus 3x plus 2 multiplied by a minus 3, and again this row minus this row, and we get b minus 2 minus 3 times a minus 3x plus c minus 2 times a minus 3, and it's the remainder, and this remainder must be 0 because it's a factor, or a given polynomial p of x is equal to this multiplied by this without remainder. And since it must be 0, it can be 0 when this coefficient in front of x is 0, so b minus 2 minus 3a plus 9 should be 0, and b is 3a minus 7, and also here c minus 2a plus 6 should be 0, so c is 2a minus 6. And it's the required relation. Find an expression for b in terms of a. The next can show that the only way to assign the values is a is 4, b is 5, and c is 2. So since there are only 5 numbers in total, let's consider each value. So if a is 1 or 2, we can see that b is negative, which is impossible. So b is negative, so this cannot be negative, implies that a cannot be 1 or 2. Let's consider a to be 3. If a is 3, b is 2, but c is 0, and c cannot be 0. And since we need a to be 4, it's correct. Let's consider incorrect value. A is 5, or when a is 5, b is 15 minus 7, it's 8, which is also impossible. Hence a is 4, it's the only variant. Hence b is 3 times 4 minus 7 is 5, and c is 2 times 4 minus 6 is 2. The next, express p of x as product of linear factors. So our p of x, which is a is 4, so it's x cubed plus 4x squared plus 5x plus 2, and it is equal to x plus a minus, it's the result of the division, it's also a factor, so it's x, and a minus 3, it's 4 minus 3 is 1, so it's x plus 1, and multiplied by another factor, which is x squared plus 3x plus 2, but we need x squared plus 3x plus 2, it's also can be rewritten as a product of linear factors, so it's x plus 1, x plus 2, so finally it's x plus 1 squared multiplied by x plus 2. Linear factors. Hence, otherwise sketch the graph of y p of x, clearly showing the coordinates of any intercepts with the axis. So we need to plot a graph of a given of this function, and since it's a polynomial of degree of 3, if we consider the greatest power, we can see when x tends to plus infinity, it's very large positive, y also tends to plus infinity. So when x increases, y increases to plus infinity, y also increases to plus infinity, and when x tends to negative infinity, y also becomes very large and negative, so y also tends to negative infinity. And when we can see the x tends to plus or minus infinity, we consider only the greatest power of x, because other terms will be much less. So function looks like this, tends to plus infinity here, minus infinity here, and we can see that there are two roots, -1 and -2, and we can see that there are two equal roots, or we can see x plus 1 squared, and it looks like a parabola touches the axis, so you should be able to plot such graphs. So it looks like this. It's because there are two equal roots, so it touches the axis. So it's -1, another root is -2, and it tends to plus infinity when y tends to plus infinity when x tends to plus infinity, and y tends to negative infinity when x tends to negative infinity. So it looks like this. And y-intercept, it's easy, it's 2. It just c is 2, or here when x is 0, y is 2. So it's the required graph of p of x. And that's all for this question.